PSC. I am Christian Paul Boaya Liza.
I am Lydia Jamiri.
I am Nathan Angeline.
I am Almira Mama.
And today we will perform lab experiments about physical properties of fluids. The materials in the experiment are shown. First, we have three fluids. We have cooking oil, water, and a fabric conditioner.
A glass or a plastic cup and a coin for measuring the viscosity of the three fluids.
A blade for surface tension of the liquid.
A soap, a transparent tube which has a 10 millimeter diameters for determining the capillary rise of the fluids, a pen, a notebook, and a cell phone for a timer.
The first experiment we will perform is the density of the fluids. First, we have to prepare the needed materials, the cooking oil, Fabcon, and water. In an empty cup, we need to put an ample amount of each fluids. As you can see, when we put the Fabcon and then oil, the oil floats, which means that the oil is less dense than the Fabcon. After that, when we put the water on the mixture, the oil remains to float and the Fabcon remains below the surface of the cup, which means that the Fabcon is denser than the water and oil. This shows that these three fluids have different density from each other.
Determining the viscosity is the second experiment we will going to perform. Unlike in the first experiment, we will have different container in each fluids. And to perform the experiment, we will be needing a coin, notes, and a timer. Hazel will drop the coin while Almira will measure the time of the coin until it reaches the bottom, and Christian will record the time. In the experiment, we can see that the coin took longer to sink when it dropped in the oil and fabric conditioner, which took 0.4 seconds, than when it is dropped in the water, which took 0.3 seconds. Viscosity is the resistance of fluid to flow and how thick is the fluid is, or its consistency. And to determine the thickness of the fluid, we measure the time of the coin took to reach the bottom. The more viscous or thick the fluid is, the longer the coin took to sink. Therefore, we've shown that fabric conditioner and oil have higher viscosity than the water.
The third properties of fluids that we are going to perform is surface tension using a thin object. Using the liquids in the different plastic cups, Lydia will slowly place the blade in a vertical position, and after which, Almira will slowly place the blade in horizontal position. We will observe if the blade sinks or floats in three different liquids when placed horizontal and vertical position. Hadel will give the remarks in each fluid. Surface tension is directly dependent upon intermolecular cohesive forces. The experiment shows that when we place the blade on a vertical position on three different liquids, the blades on water and cooking oil sinks at the bottom. But in the Fabcon, the blade floats. It is because when the object is less dense, the object will float. That is why blade floats on Fabcon. When we drop the blade horizontally, the blade sinks on cooking oil and floats on water in Fabcon. It is due to the surface tension of the liquids. It floats on water in Fabcon because blades are less dense among the two liquids. Since the fluids have different consistency or the viscosity from each other, it affects the surface tension of the fluids. Moreover, the bigger the surface area of the object, the bigger possibility it will float, except an oil because the cohesive force that the oil has was not enough to make the blade float.
For the fourth experiment, we need to form a bubble using soap. In this experiment, we use a detergent soap. We put the soap in the water and rub it in our hands to form a bubble. Then, we create a bubble by blowing the forming bubbles in our hands.
As we have observed, the bursting bubble has to do with surface tension. Adding soap to the water decreases the force of the surface tension. Surface tension is the reason why bubbles blown away burst. We are creating force when we blow the bubble, in which it causes the bubble to pop.
Now, for the last experiment, we will do the capillary rise. Lydia will vertically immerse the 10 mm diameter tube in the glass containing water. Christian for the glass of oil, and Hadel for the glass of fabric conditioner. After that, we will measure how high the liquid will become after putting the tube in the cup. As we observe, the height to which the water rises depends on the diameter of the tube and the temperature of the water, but not on the angle at which the tube enters the water. The smaller the diameter, the higher the liquid rises. Water rises in the capillary tube due to adhesion between water molecules and the glass walls of the capillary tube. This adhesion, together with surface tension in the water, produces an effect called capillarity, with a characteristic concave surface. The height of the capillary is below the original height of the liquid. For the oil have a convex meniscus which is smaller to that of mercury. Such a liquid cannot form strong interaction with the polar SiOH group of plus or silanol groups that are generally hydrophilic or water-loving, so the surface of the oil inside the capillary are lower than the level of the liquid in the beaker. The height of the capillarity is higher than the original height of the liquid. And for the fabric conditioner, we cannot see the visibility of the capillarity due to the thickness of the liquid and its color.